So hi, I'm Ondřej Pinta. I'm from O2 Czech Republic, which is a Czech telco company. It focuses on mobile devices, it's a DSL provider, and also it provides its own television. Right. I'm working in O2 data science team. We have around 13 people there. My team consists of about 3 people, and we work on a lot of tasks that you would imagine telco company does, such as churn prediction, customer segmentation, and lately we've also been working on a bit of a research application when we are trying to classify transmission towers into certain clusters in a way that's similar to Word2Vec. Today I will talk about interest classification. As you can see the categories here. It has a loose grouping of categories at the start and something real specific in the end. I will start with the motivation and overview, why we do it and how is it exactly done. Then I'll describe the platform it runs on and end with utilizations we have for interest classification. As of now, we have about 700 million HTTP requests daily, which is not as huge number as some other companies that are here, but it's still not that small. We have around 830,000 DSL users. Those are just those that are active. And about 2.2 million mobile SIM cards. Again, those are just the SIM cards that also use data, not just the voice. With these numbers, O2 is has about 1/4 of customer market in Czech Republic. All right, as we call it, cesium interest classification, it's just one level classification. It has no hierarchy, and the reason is that we found out that it's rather confusing when it has that. So it's just a single, but there are some loose groupings that show, and I will show later, that they actually have some meaning and some coherence together. Right. And also, this is a long-term interest classification, which is important to keep in mind. It isn't just over a few days, or as you could call it, it doesn't catch some attention of a user who is looking to buy something in a certain time, but rather some long-term shifts in user behavior. Those short-term interests could be used for a variety of things, which we also have, but this one should represent a user as a whole. What platforms do we use? We have Hadoop platform, and you might have been to other presentations about what exactly can be run on Hadoop using containers, etc. For now, we are using Hortonworks that is provided to us by Teradata. And for scheduling, we have Uzi, Spark for analytics itself, namely it's PySpark. And we use Hive for pre-processing and post-processing of the data. Afterwards, after the segmentation itself is done, the data is then distributed to Teradata Aster and Teradata Warehouse environment when the rest of the company can work with it. So, how is it done exactly? I will take you through the whole process of creating a classifier of online interests. At first, you need to define the categories themselves. You can do it in many ways, but we decided to define categories as a set of keywords. Those keywords were discussed with business, and then we put it into the Google API and got a long list of URLs. From those URLs, we parsed single words. For example, if you have www.nike.com running shoes, it would be Nike. We would omit the stop words and running shoes. Out of this, this is a sequence of 3 words. Out of those, you would create bigrams. So it would be Nike, running, running shoes. In case of longer sentences, it would be, again, more bigrams. We found out, or it's actually proven, that this contains a lot more context than using just a singular word. Because for shoes, it could be shopping for shoes. When you have running shoes, it's quite obvious that it still can be shopping for shoes, but also it can be correlated with sport. When we have those, we can create the classifier itself. Once the classifier is created, it can be saved, and afterwards, we take the data we have, the HTTP request, the 700 million, which we score on a daily basis. And the classified web pages are saved. Once those are classified, there's the magic we do actually, because you can have just the number of web pages, but that's not interesting to the business user. You need to have something actionable, something understandable. So we create percentile points for each interest for each person. So you can see how you compare to the rest of our base. For the algorithm itself, it's quite simple, at least in this iteration. It's term frequency and inverse document frequency. It's not important to go into detail with this. And we use a naive Bayes classifier, which you might argue is not the latest classifier, nor maybe the most precise. However, we found out that the accuracy is just enough for us, and it runs really fast, which is really helpful in case when you need to classify 700 million rows, right? For the classifier, because we had a task to have a certain accuracy, that the classifier should be good enough that it will make too many mistakes. For this, we decided to make a cutoff, to classify only part of the traffic. And in the end, it ended up that we classify only about 1 in 100 web pages, which is not much, but it gives accuracy of around 90% in 69 categories, which I think is not bad at all. However, there's one thing that everyone who's working with such data might notice. There's a difference between training and testing data. As you might recall from earlier when I was saying about the scraping Google API, there you get really nice URLs. But in this case, when you're trying to classify your daily traffic, you find out that there's a lot of ads, there are tracking pixels, there are, for example, some applications that run on HTTP. So it's not that easy to just take the classifier and transfer it. So what had to be done afterwards was manual checking of the categories. And we found out that the actual accuracy is about 10% lower because of the dissonance between the training and the testing set. And I hope you can see this well. But this is an example of categorized interests, and these are mine interests. So this shows how I compare to the rest of the population. So this is about 99, I would say. This about 90. So as you can see, I like comics and animation and programming. So I'm a bit of a geek, but I admit to that. Right. So what was the utilization of segmentation of online interests? There are quite a few, actually. It's been used for internal products, for internal segmentation. For example, there was a new line of O2 TV packages that was being pushed to the customers. And it helped to market it to people who liked sports, because there's a lot of football there. Also, there were tariffs for families, so we can target people with interest in raising kids, etc., which can surrogate a family. It's a customer segmentation itself, but it can help for further segmentation, as I will show you on the next slide. As we find out, it's also kind of important for churn prediction. We tried modeling churn that is caused by people moving to a new locations. And it turned out that one of the predictors is actually looking for home improvement and home furnishing, which makes sense if you think about it. And last but not least is the external targeting. We work together with other companies to tailor targets based on their needs. And again, the prediction or the segmentation of online interest is in high demand in this sense. So we have a lot more models apart from the online segmentation, and one of them is the prediction of gender. And as we found out, there's quite a bit of a difference in some of the interests between the genders, which kind of makes sense. As you can see, the interest for which the women are most affinite are babies, crafts, face and body care, furnishing, toys, etc. And here you can see what I told before. There are groups of interests that are placed together, even though it's only a contextual placement, not a hierarchical one. All right, this is the other part, the other segment. This is men. And here you can see it's more computer, games, sports, and cars. Right. So, what did we do here and what are the next steps we would like to take? This classifier is automated. It runs on a daily basis. It takes the input data automatically, classifies them, transfers it back to the warehouse to the business users to use. And it is done automatically and the problems are reported. Today I heard a talk about how the performance of the model should be monitored and reported on a daily basis. We have that too, actually, and it's reported in a Shiny app. And you can see graphs and developments of how many people were classified in which category, if the classifier is stable, what's the accuracy, etc. Right now, it's used throughout the company. There are many business users, and it's being used in other models as well. And what are the next steps? Where do we want to move this kind of interest segmentation? Well, we want to try to scrape the web pages and classify the content, which is kind of logical next steps, because so far it's being done just from a simple URL parsing. But even then, it can work fairly well. The scraping web pages would require also using some other methods. For example, as I'm saying in the lower part of the slides, neural nets, some other classifiers that can work, for example, with word embeddings. And right, yep, that's it. Thank you for your attention.